Monthly Space News, obviously representing 1 month of things that happened in space. So one big thing that happened is the Starship test. This is test number 2. Most people probably remember the first one, big explosions, concrete all over the place, that sort of thing. There was a long wait for approvals, Fish and Wildlife actually being the last one. Finally, they got all that, and they launched on November 18th. Some of this got misrepresented. The plan was never to actually go into orbit. They went into space, and they got very close to orbital speed, but they didn't want to go quite all the way. They wanted to just end up landing near Hawaii. They didn't get quite that far, but even getting as far as they did was actually more than they expected necessarily. So they did achieve their major goals. A lot of these actually go back to fixing the deficiencies noted on the very first test. The first thing is the launch pad itself. They call it stage 0. As you recall, it did not stand up to the wrath of all those engines. So they'd installed this water cooling mechanism, which did a lot of things. Basically, it absorbs a lot of heat by vaporizing the water. It breaks up standing sound waves by the fact that there's all these different levels of humidity in the steam bubbles. And as a result, it breaks up the sound. The net result was minimal damage. The problem can be fixed pretty quickly and would probably be typical in a lot of launches. The next thing is that all the engines did work this time. They didn't work last time. This time they all did. Actually, both on the first and the second stage. Yeah.
Just a reminder that SpaceX rocket is taller than a Saturn V rocket and more powerful than Saturn V rockets. That's what is taking off.
Okay, you have been warned. Okay, if you've watched any of this, they show you a lot of information on these displays. Like this display down here is telling you what engines are firing in the booster. Yeah.
Short question. Wasn't this the design of the engines that the Russians were using back when they were trying to go to the moon and it didn't work?
The pattern, yeah.
The pattern.
M1.
Oh, you're talking about the
multitude of
that pattern of engines with the same style that failed, and they gave up.
They gave it up, yeah.
Well, yeah. They had 30 engines on the first stage, and they did not have real good computer control back in those days. And it caused problems when some of the engines started to back surge and chug. It caused another engine way on the other side to start going crazy, and then everything just went.
I thought it was a very interesting history. That's right.
It is. Yeah, there's much tighter control on all these things now. Well, and they made a lot of improvements. I mean, for instance, in the previous generation, it was all hydraulic controls, and there was a common failure mode that if you lost your hydraulics, you pretty much lost all your gimbaling, your ability to move the engines around. So a lot of things got fixed up between version 1 and version 2.
I didn't mean to slow you down, but I thought.
Oh no, this is a lot of interesting stuff that that happened here. There isn't time to go over all of it, but there's an amazing amount of stuff that they do. They always say like 1,000 changes or whatever, in each one, all small incremental changes. I mean, even the engines got upgraded to slightly better versions than what they had before. They put in better separation between the engines so that if one of them caught on fire or blew up or something, it wouldn't necessarily stop the rest of them. They could lose 1 or even 2 engines and still make it to orbit. And, they show you the altitude and so on, rounded off, obviously. It's obviously more than 0 at this point. Okay, continue on to the major goals. A big thing was they changed the way they're separating the stages. The first time what they were planning on doing was essentially just rotating everything and letting things spin apart. They never actually quite got to that the last time around because they weren't at the point where it's time to separate. But anyway, they went to a new method where they just fired the engines of the second stage while the first stage is still running. Now, they do cut it back. They cut back to 3 booster engines. And then they start up stage 2, and then they separate. And they claim, 10% improvement. So anyway, that worked. There's a picture of that. It's probably a little hard to make out. What you're seeing here is the booster to the left-hand side of that, and then you can see the rocket firing of the second stage there. They're up high enough that they're already over at quite an angle. Continuing along, the next step is the booster would flip. In the future is going to be heading back to the launch pad, or at least back to somewhere closer to shore. They're called the boostback burn. And so they actually managed to do the flip. That's the first murky picture here, where they're starting the flip. The flip is going like 45 degrees at that point, and there's the second stage firing its engines in full. They got all the way over, and they got ignition. You can see a little bit of that. That's just the booster in that middle picture. And then on the far right-hand side, they actually had a couple engines going. But the whole thing only lasted about 7 seconds, and then it blew up. Now, it's unfortunate because, the news says, oh, okay, they had major explosion. Well, actually, any first stage is always toast after it's done. I mean, normally they just fall to Earth, and in this case, it happened to blow up. But the main thing is they're making progress. They're getting past just throwing away the stage. They at least managed to flip it and get it coming back, which is what they do with the Falcon 9. I mean, they've got that down, but this is a different set of engines. It's bigger, everything's different. So they're working on that. So anyway, they were actually pretty happy they got as far as they did. I don't think they actually know exactly why the thing blew up. There was a lot of speculation. I mean, some of it's, okay, the fluid's sloshing around, there's that. Maybe just the forces were too strong. I don't think that's it, because the first test showed that the whole thing could flip around multiple times and hold together. So it probably wasn't a structural problem. And of course, there's always the fact that, well, you are blasting the top of the booster with the second stage right before separation. So that could have damaged things to it. They'll sort all that out. So anyway, that's what it looked like. That was the booster exploding. So it broke up, as I said, about 7 seconds in. Everybody seems to think it was the Flight Termination System that did it, meaning it decided that things were not going well and it blew itself up. And that is what the Flight Termination System is supposed to do. So actually, I guess we've now tested out that indeed the new Flight Termination System works. It didn't work on the first one very well. That was considered one of the major problems they really had to fix. So here they've indirectly done a demonstration that flight termination works. Again, the underlying root cause, maybe they don't know that yet. But anyway, the point is, the second stage still took off, from that point, just like any other rocket would have. So they don't feel too bad about that. Continuing along, the second stage fired for another 6 minutes. That was about 3 minutes in when we had that explosion of the booster. But, the second stage had already gone past that. And it ran for about 6 minutes, almost getting to the point where it was supposed to go. Didn't quite get there, and then it blew up. And that, again, probably Flight Termination System. They don't actually know why, or at least I hadn't seen anything yet as to what actually happened here. But that was pretty good. And of course, assuming it was the Flight Termination System, then again, it's doing what it's supposed to do. We just don't know what decision went into it. The reason they can't tell is they lost telemetry. So there's obviously a problem there. Somehow or other, they weren't getting the data anymore, and so they couldn't even tell what happened. But they got up to about 148 kilometers when they were still getting telemetry, and they were going about 24,000 kilometers an hour. So they're getting pretty close to escape velocity, pretty close to the altitude they wanted anyway. But they didn't get a chance to try out reentry. So that's one big thing that's missing, and that was a stretch goal, which is the next thing. Obviously, they hoped to take the first stage further. They weren't planning on coming back and actually doing a landing, but they were hoping to prove they could control it on the way down. And that was a stretch. They didn't get there because it blew up. The second stage, they wanted reentry at full speed to really get a good test of the thermal protection system, meaning the tiles, basically. These are new tiles, new gluing methods, and so on. And it turned out some of those tiles, not a lot, but some had fallen off, especially along weld lines near the base of the thing. So there's some doubt that it would have survived anyway. There's a lot of debate about that. I was reading that online, and people said, well, you have the stainless steel thing underneath it. You can always lose some tiles, and that was even true for the space shuttle. You could lose some tiles. It depends on where they are. And the good thing is that most of these tiles were just along a cylindrical body. They were not at like a bleeding edge where the air is hitting at supersonic speeds. So they probably could have made it, but we'll never know because the thing blew up. One good thing is that at least given how far they got, the next set of approvals for the next test shouldn't be so hard to get. So they were pretty close. Okay, next topic, a competitor to SpaceX, which is Amazon with their Project Kuiper. Now, they're not a competitor in a launch. That's Blue Origin, which is, although it's owned by Jeff Bezos, it's a completely separate company. But Project Kuiper does compete with the Starlink internet satellite communications business that SpaceX has. And as a reminder, SpaceX wanted to build that business because it's a much bigger business than the launch business. So they needed something. If they're going to pay to go to Mars, they needed cash. And so one way to do that is to build a much bigger business than the launch business. And actually, Starlink, it was probably like a $10 billion kind of project, too, over a period of years. Kuiper, you would expect them to have higher costs, partially just because of inflation and partially because the rockets they were using. Anyway, Project Kuiper, it is satellite-based internet service like Starlink. They finally got a launch back in October 6th, and within about 30 days, they concluded it really was a success. Everything worked out the way it was supposed to, meaning the satellite, the propulsion for raising and lowering orbits worked, the actual transmissions, and in particular, they demonstrated 4K video streaming, two-way video calls, and also buying something on Amazon Prime. Of course, they had to do that. If you're going to be Amazon, you're just offering an easier way for more people to buy stuff.
Satellites that went up.
There was a question on the rocket used for the test flight.
They went up on an Atlas V. I guess nobody really knows how tightly they're going to pack them, but in theory, that probably could have held 20 to 25 of their satellites. But they were so desperate. The problem with them was they bought up all the spare capacity for rockets that haven't actually yet flown. The Ariane 6, which is not actually ready yet in Europe, and Blue Origin doesn't exist yet. And also the Vulcan out of United Launch Alliance. All these are rockets that have not actually flown yet, and that's where they bought up all their launch capacity. So we'll get to that because it turned out they finally broke down and ordered a couple for SpaceX as well. But anyway, so they demonstrated the satellite works. Deployment is really going to begin in earnest now. Mass production of the satellites is going to start in December. They got a factory in Kirkland, Washington. Launches should start in the first half of 2024, and with beta testing of the users late 2024. Now, that's their schedule. I don't know if they can meet that or not, because it takes quite a few satellites to make a reasonable beta test. And it's kind of questionable if they could actually get that many up very fast. They have about 3,200 some satellites that have to go up there, and they have to get half of them up by 2026. So Kuiper, as I said, is internet service from satellites. Very similar to Starlink, but there are some differences. One difference is that they're really pushing integration with Amazon Web Services, that since they own that, the infrastructure. And that's something that actually is sort of a vertical integration issue. That's something that SpaceX doesn't really have. They're working independently with other companies like Google and others for some of that internet infrastructure tie-in. The other thing is they already had some ground stations in place. They were trying to set up a ground station as a service kind of a thing. They already had 6 in existence. They use the words ground station, and to most people that just means communication between a satellite and the ground. It's the equipment to do that, something beyond what a user would do. And 12 is not enough. Maybe you could cover the US with that. Starlink has at least 20 at this point. But starting off, they would have had fewer, and so maybe that's okay. But there's the whole rest of the world. And with their architecture that I'll talk about in a minute, they really can't talk or do anything over the internet without having ground stations nearby. Ground station, in the case of Starlink, it covers a footprint of roughly a circle of, say, 700 miles, something in that range. And, you imagine, okay, 12 of those, you could place them around the country, and you'll probably cover most of at least the continental U.S., probably not Hawaii and Alaska, but at least you could get that. But anyway, minor differences. They have slightly higher orbits, but they're still pretty much in low Earth orbit, not that different. We talked about Hall effect thrusters the last time for some deep space stuff, but all the satellites pretty much use them. They're using Krypton in theirs, and that's like the previous generation for Starlink, because Starlink moved on to Argon, which will cost 1% of what Krypton costs.
A question came up on the effectiveness of Argon. Isn't its reaction mass less than Krypton?
It is, and yet when Starlink people did this, they ended up doing a more powerful engine somehow or other. So somehow or other they advanced the technology. But there may be a bigger difference from Starlink, at least initially. Apparently, they don't have any links between the satellites. Now, actually, Starlink didn't either in the beginning. They always said they would, but they couldn't get it together in time. So they've launched quite a few satellites without them. Maybe Amazon is just doing the same thing. You can't tell from their public announcements. They have all kinds of nice drawings of what's going to happen with their system. None of them show any links between the satellites. And it turns out that actually has a big impact. So maybe they'll do it later, just like the Starlink people did. In the case of Starlink, they say they have about 8,000 links right now, which means laser-based communications between 2 satellites. You'd have to have at least 2. You'd probably want to always go for in the same orbital plane, like think of a big circle full of multiple satellites. You'd always want to shoot out to the one ahead of you and the one behind you. So you'd need at least 2 per satellite. You probably want another 2 for going to the side. So you'd probably have 4 per satellite. I don't actually know what they're doing, but that would say maybe 1,200 satellites already have this out of the 5,000. So it's a significant proportion, but it's not complete. Now, one thing Amazon did say is they are going to have some laser links to U.S. military satellites. And that's because there's this program we talked about a couple of months ago, the Space Development Agency, which is part of the military. They're setting up constellations of satellites with laser-based communications, and they're going to have a standard for that. And I guess Amazon has said they will participate in that. So they're not afraid of doing it. And I think in their early FCC filings, they mentioned it in passing, but it's not obvious that they're doing it right away. Anyway, why is this important? And really, this is what this picture is all about here. Here's the standard case that everybody expects to be using, or Amazon wants to use. Left-hand side here, you got a user. Maybe it's somebody in their house, maybe it's a business, or it could be a cell tower for a phone company that's just isolated and not connected to the internet in any way, out in some remote area. They're making a point on their website of advertising that particular case. So that will communicate with a satellite and then back down to a ground station. At that point, that's tied into the internet, in particular, the Amazon Web Service infrastructure. But the key thing is really the internet. So from there, you can go to other users. I've labeled a thing called service over there. That might be Netflix, or it might be just a web server somewhere, some kind of a service you're using, or it could be another user, a business or anything else. And we're showing, and they also could be remote on another terminal, as is shown on the right-hand side diagram there. So the yellow links are microwave links between ground and satellite. The red are internet. You can see a path here. You kind of bounce up and down to the satellite or along the internet, back up to a satellite and down to some other user. Or just communicate with somebody on the internet, either way. The catch with that is it says you have to have a ground station, which means if you want to cover the world with service, you've got to have a lot of ground stations, lots and lots. And that's the weakness of this particular system, which is why in Starlink, or even the old Iridium system, why they had satellite links so they can bypass all this. Large areas are just not reachable, like the ocean. What are you going to do for the ocean? I'll get to that in a minute. You can use ships, but it's pretty iffy. Now, this is the traditional model. For TV broadcasters, if you were DirecTV or one of these people, you were way up in geosynchronous orbit, 22,000 miles up. There's a long time delay between that satellite and any customer. But for broadcast TV, it doesn't make any difference. I mean, if you're getting it some milliseconds longer, it doesn't really make much difference. But it makes a difference in a lot of internet applications. I mean, imagine people playing video games, getting a huge lag. You just can't do it. Those satellites, instead of being at like a couple hundred miles up, like the low Earth orbit ones, they're up at 22,000 miles. That's a factor of 100. And the time delay is just proportional. It really matters. So that was sort of the old model, and it looks like they may be following that, at least initially. So there's a question then, well, what other cases are supported? Can you just go from one user to another just through a satellite? Probably they wouldn't do that. Now, in theory, you could, but there are some issues, not so much related to communication, but it's more related to authenticating the users in the first place. I mean, you could put in memory easily every user and their passwords. You can take care of that. But billing and handoffs from satellite to satellite, it's just harder. You can do it. Because keep in mind, these satellites, they were shown in an orbit here. They're going along over these users. They're only in view of a particular user for maybe 7 minutes or so. And that's horizon to horizon. And actually, usually there's trees and stuff and buildings in the way. So you have to have an angle. So actually, you don't really get the full distance. But anyway, billing, you could imagine you do it the way you do store and forward networks, where basically the satellite would remember that somebody was on that call. It's going to move on down, and eventually it'll pass by a ground station. It could then transmit, that user some time ago, sometime during this previous orbit, had communicated. And so they could keep track of that, but it's just messy. And then the handoffs. That says you'd have to have extra logic actually in the user terminals to keep track of, by the way, I've got an ongoing video stream or call going on. My previous satellite is passing overhead. Here comes the new one. And, you could do it, but it's harder. So we'll just say we're not sure about that. Now, what about repeaters? You could say, well, okay, like suppose you just want to go over the border into Canada, from a US-based ground station. You could imagine if you had, even if for some reason in a remote area of Canada, maybe they wouldn't have any internet access, but you could put a couple of extra ground stations in there just basically to bounce the signals around. You could imagine doing that. It does consume a lot of capacity, though. If you want to reach this guy from over there and vice versa, got to go through all these intermediate stations, which means there's that many fewer users each one can handle. So it's sort of iffy, but it could be done. But actually, you can't tell. Amazon isn't really giving that level of detail as far as I know. The downside of all this is you get a lot of time delay, because not only do you have the extra length, instead of just going, like, say, from satellite to satellite, you go up and down and up and down. There's more distance, which translates to more time delay. But also, there's more repeaters. Every time you go through one of these nodes of any type, it's got to be converted from, say, optical or radio frequency. Essentially, you're dealing with a router there, essentially dealing with electronics, computing, and it does some stuff on the computer, and then it reformats that and then sends it along to the next link. That all takes time. Every time you have a repeating unit of any type, it takes extra time. And so the more of those repeaters you have, the worse off you are. The ideal situation would be, whenever you can, you pass the signals between the satellites. Those are different transmitter-receiver pairs. They don't interfere with the normal links. So you got a guy over here talking, you skip as many intermediate ground stations as you possibly could by the inter-satellite links. And those, if they're laser-based, they're much, much faster. That's the Starlink vision. That was even the old Iridium vision, which is the granddaddy of all these. The difference, though, is that these links, these are laser-based. Nowadays, they're laser-based. Actually, you can carry a lot more data with lasers. It just basically is higher frequency. Light is higher frequency than microwaves. So you can squeeze a lot more in. And another factor is that the speed of light in space is a lot higher than the speed of light in, say, optical fiber, which is what's on the ground there. So you actually want to bypass the ground infrastructure as much as you can. Now, from an economic standpoint, if you're trying to minimize the number of satellites, it kind of goes the other way. But in terms of delay time, basically, you'd rather have most of it just go through space. So anyway, those are the kind of issues that you can't quite tell what Amazon is actually doing here. Anyway, they're going to start off with something, and they're just not saying all the details. The interesting part about Amazon here is that they finally decided to go for Falcon 9 for some of their launches of their satellites. I think they were kind of forced into it because some of their own shareholders sued them, saying, you guys, you didn't go for the cheapest launches, which would be SpaceX. They definitely beat everybody else. They have availability, and the others didn't, including Blue Origin, which was one of the Bezos companies. So there was a lawsuit about that. I think ordering 3 launches is slightly more than just token. It's probably perfectly calibrated. If you just got 1 launch from SpaceX, that would say, okay, that's just a token effort to shut down the lawsuit. But you do 3, it sounds a little more convincing. The other hand, it is probably something they absolutely need to do to meet their license requirements. They've got to get a lot of satellites up, and they're really the only show in town at this point is SpaceX. Because they have reusable boosters, they can get a lot more stuff up to orbit. Nobody else can do it. They just can't maintain that kind of launch cadence. The cadence is the word they like to use, just meaning high frequency use. And there's actually another factor a lot of people have pointed out, and that's that probably Amazon won't actually meet their deadline to get half their satellites up by 2026. So what they'll do is they'll file for an extension. And if they've already clearly made efforts to at least alleviate the launch shortage, that kind of takes care of that problem too. So I think they in reality need to do this, and in fact, it solves several legal problems along the way. So it's all good for them. As a result now, actually every single Starlink competitor uses SpaceX, every one. The only one that doesn't is DirecTV, but they're not launching anything. But that includes the other direct competitors, which are this first line here, the OneWebs, the O3Bs, Telesat, which is coming along. They haven't launched yet. That is a Canadian operation. There's the old line geosynchronous satellite providers and the ones that are more focused on voice communications. All of them have launched on SpaceX. They just have no choice. Okay, well, last major topic here, kickstarting a commercial lunar economy. And it probably surprised a lot of people. This is coming out of DARPA, which is a Defense Department organization. They have a thing called Luna 10, and it's meant to be a 10-year project figuring out basically how do we build an economy in the moon. And that's their goal, is develop an integrated architecture. Now, mainly they're talking about a framework for it. They're not talking about actually building it themselves. This is DARPA. They don't do that. They're more putting things together than letting commercial partners actually build the stuff. They want to get a self-sufficient commercial economy going by 2035, but kind of an ambitious goal. They announced it back in August, and then recently they've selected a bunch of companies, which is what drove it to be in today's news. For those who don't know what DARPA is, it's Defense Advanced Research Projects Agency. It was created back in '58, essentially in response to Sputnik, the Russian launch of the first satellite. Their mission statement is to make pivotal investments in breakthrough technologies for national security. It's interesting. I'll get to why are they involved in the last slide on this. Their focus is on major transformational changes. They don't fiddle around with little incremental stuff. They essentially do R&D funding and program management. They only have 220 people, and that's an increase. They used to only have like a couple hundred. But all the way going back to '58, they have played a major role in an awful lot of major technology advances. Essentially, they did invent the internet. It wasn't Al Gore. It wasn't literally them. It was the programs that they were funding. They were working with Vincent Cerf and those kind of people between the academics and the industry. They made up all the protocols for the internet. They implemented in the case of ARPANET, but like TCP/IP, which is a standard protocol set for networks, they invented all that. GPS, it really was pretty much them. They do things like sponsoring contests, and they've done that for autonomous vehicles, robotics, computer operating systems, the multitasking operating system, Multics, it kind of set the tone for almost everything that came after that. The drones, even messenger RNA vaccine, they funded Moderna when they were coming up with this stuff. So they have a good track record, is what I'm saying. So it's kind of interesting that they're coming into this. So they have an initial study. The first is just 7 months. And their funding turns out 14 companies. They didn't specify the number, but they've done 14, up to a maximum of $1 million each on this phase. And the results will be presented in April at a NASA conference on Surface Innovation Consortium, and with their final report in 2024. They picked 14 companies. The work areas that they're working in are communications, navigation. You can kind of expect it, but it says they're trying to think, what are all the things that have to come together and work with each other? And that's really the key, is that what they saw was an awful lot of efforts going on where, this company is doing 3D printing with lunar regolith, and this company's doing that. They're trying to visualize how it's all going to fit together in an actual economy. Okay, so construction, robotics, market analysis, just figuring out who's going to buy what. That's actually one of the hardest parts of the whole thing. Mining, in situ, research utilization, power. How do you get your power? Transit, so mobility, logistics, that kind of stuff. In their August announcement, they also listed some other areas that are obviously going to be important, and they weren't addressed in this first go-around. So probably either they didn't get enough responses in the other areas, or they're just not ready to deal with it yet. But there's a couple that strike me as being absolutely essential. Agriculture and life sustainment. You got to work out an awful lot of details there if you're really going to have somebody living on the moon as opposed to just visiting for 5 days. So the 14 companies, they all supposedly offered a clear version and technically rigorous plans. And these are the companies, and a lot of them we've heard of, the Blue Origins and the SpaceXs, and then there's some smaller ones in there as well. They didn't actually mention in their press release what each company is doing, but some of the companies have mentioned what they're doing. For instance, somebody is building on a robot. Firefly Aerospace, you might think they're building engines or something, but actually they're building spacecraft hubs to host and service, in particular to service spacecraft. Cislunar Industries is going to extract stuff from lunar regolith, mining and water and that kind of stuff. So anyway, they've identified some initial roles for these companies to start working on. And the key thing is to kind of put them together and say, okay, if you guys are trying to build the economy, what do you have to supply to each other? They're just kind of working out at the high level. How's it going to fit together? There's a lot of questions. Why is a military organization getting involved in it instead of just NASA? It's an obvious question. A couple parts to this answer. First of all, it complements NASA efforts, and that's what they have said, and I think they're right. Basically, NASA doesn't do what we call space development, which actually is what NSS is all about. The space development meaning building an economy, building permanent structures, eventually settling with people. NASA doesn't really want much to do with that. That's really it's just not their thing. They don't do that. And they say it pretty explicitly. They focus on science, first of all, and they focus on exploration. And that includes robotic exploration as well as human. And they're doing that, and they do a lot of that. They do a good job. But space development, that's not their focus. And they don't really believe they should be doing it. They don't really believe Congress wants them to do it. So, for instance, what we end up with is kind of the flags and footprints operations. We're going to go and we're going to drop off people on the moon for 5 days as practice for going and dropping off people on Mars for 20 days. That's not really building an economy. That's essentially just tourism. And so what they're saying is, really, NASA's not doing this. Somebody ought to step up and start putting all this together, and they're offering themselves. One thing about them is out-of-the-box thinking. That is definitely their strength. That is their specialty. That's what they do, and they have an excellent track record on that. And part of that is they're not constrained by political considerations. NASA is. They have to keep jobs for the people who built the space shuttle. They're not hindered by that kind of stuff at all, and that's actually a big help. It goes a little deeper than that, though, and it really comes down to strategic thinking. Because NASA's goals are fundamentally science and prestige, meaning the flags and footprints put people on Mars for 5 days, they're not really thinking strategically. Well, the military is used to thinking strategically. That is what they do. And of course, their main charge is national security. But that really, in national security, is kind of broad. It really includes economic interests as well as purely military kind of stuff. Like, they worry about the strength of the industrial base because they know that they can't defend the country if they can't build the weapons that are needed to defend it. And this is sort of an extension of that kind of thinking. Because realistically, what's going to happen in space is kind of a squatter's rights kind of a situation. Whoever goes there, and by there, that could mean landing on the moon and building a base of some sort. It could mean putting a space station at a Lagrange point, a place that's a natural place that doesn't require much effort to keep it in place. There's a couple of places for those, or just orbits that are strategically important. Whoever gets there first, even under the Outer Space Treaty, pretty much says they can keep it. They don't have to own it, but they can say, well, you can't really bother me. You can't come here because you'd be interfering with our operations. And that's pretty much what's going to happen. And that's even consistent with the Outer Space Treaty. And related to that, it comes down to some of the military goals, for instance, include freedom of access of the seas on Earth. And that's why you see these disputes come up. China's the big example here with the South China Sea. If China says, you can't go through this water without applying for a permit from us in what's clearly international waters, even by other treaties, That's what they see happening. The Chinese have pretty much said, South China Sea, we're going to do that in space. Basically the goal is fill it up with stuff and then gradually restrict others' access to use it. And so, what they're saying is, we've got to do something about that because NASA's not going to. That's not a NASA role, or at least they don't see it as their role. And DARPA, they're not violating the Outer Space Treaty in any way because they're not really building anything. They're not putting any facilities or even doing any testing on the surface of the moon. They're really just coming up with a framework, and then companies or governments will do the rest. Okay, miscellany. The Psyche probe, this is the one going to the metal-rich asteroid. It was launched back in October. One of the tests they had on there was laser communications. We were talking about that for lower satellites, but really, people want laser communications to work over very, very long distances. They're going to try it all the way out to the asteroid belt probably, and they're not very far yet because it hasn't gone very far, but they are testing it. And as of November 14th, which is a month ago, they were already out about 10 million miles away, and they are communicating by laser communications, and that works. So they're going to keep on trying that, but already they've broken records. Okay, we're down to that point where we say, take a guess. How many launches have we had since the last meeting? A reminder here, a distinction that matters, we don't include launches where there was no intention to go to orbit or higher. And that means we don't actually count this SpaceX launch, the Starship, which is shown here. Any guesses? Okay, you got a guess of I hear 25. 23. 30. Okay, actually, unfortunately, you're all kind of high. It's only 18. Sorry, so it's actually kind of a slow month by today's standards. Now, by the standards of a couple of years ago, this is still pretty impressive. I'll just highlight a couple of things here. You can get an idea for what countries are doing what here. As usual, there's a large number of satellites going up on Falcon 9s for Starlink. That's actually the biggest number of missions. O3b is a competitor for Starlink. They got launched by SpaceX. And of course, there's a bunch of Chinese satellites, which are all dual use. Everything they do is dual use, meaning, yeah, they're going to observe things for science purposes, but also like ocean observation, what it means they're going to be able to track, the growth of algae in the ocean as a result of climate or something. But it also means they're probably trying to track submarines too. They're all going to do that in the same satellites. North Korea succeeded in getting a spy satellite launched with this Kolyma-1 rocket. This one actually made it. So now they have a satellite up there. And of course, they've been bragging about that, claiming that, oh yeah, they can see Washington and this and that. Who knows? They got it up there. There's no doubt that it went up there. The only question is how well it works. We don't know. We talked about all these satellite networks. SatNet is one of the ones out of China, and they had a test set just launched for that. The South Korean military, probably in response to the fact that the North Koreans launched something, they launched one, but on a U.S. launch. And here's a sea-launched internet satellite demo. So the Chinese are definitely very experimental. They'll try everything. They do have a long history of having a lot of solid rocket boosters for military use. And as a result, they are continuing to use a lot of that. And they're doing that from ships and everything. If you're going out on a ship, you probably want solid rockets.
A question came up, why would the Chinese want their own satellites for internet?
Well, because they're afraid the Americans will dominate with Starlink and now Kuiper coming along. I mean, why do they have their own GPS system? And why do the Russians have their own GPS system? The same reason. They don't want something that could be stopped by an enemy.
A question came up, why would the Chinese want to do a sea-based launch?
They're rapidly building a lot of launch sites and so on. They just need more. But also, part of that is, for them, it's never just science. It's also being able to expand your influence, and doing things at sea is demonstrating that you can launch stuff from the sea. And so they like doing that, but it's also just practical right now as well.
Doug wondered if China would soon be launching from the South China Sea, part of projecting power.
Well, I think it was launched by South China Sea. Well, yeah, everybody better stay away.
Robert commented that the Chinese ZQ-2 launch was a big deal because it was the first methane-fueled rocket to put a payload into orbit.
Isn't that methane, that's a big deal.
Yeah,
Very.
it is.
They put one up. Now, SpaceX's big ship is going to be methane.
Yeah. Right, but it hasn't actually made it to orbit. There's several tests. One is making it to space, another is getting up to orbit, but with a dummy payload, and the other is being confident enough to launch it with actual payloads. And this is their third launch. The first one failed. The second one succeeded, but it just had dead weight in it. And this is the third launch, and this one actually
put payload in orbit. Robert also asked if the Big Blue Origin rocket will use methane.
Yeah, it is. Yeah. But also it doesn't work yet.
The one they haven't gotten into orbit.
Yeah.
Doug brought up that the new Vulcan rocket from ULA, the United Launch Alliance, will use the same methane engine from Blue Origin.
So one last comment, by the way, about this ZQ-2, which is a methane-based rocket. One thing about it, it's not a big one. It's probably smaller than the Falcon 9. But what's interesting is they're even going to switch over to using stainless steel, just like Starship. They've announced that that's coming, not clear when, the earliest next year, but they're also working on that. Okay, I think that is it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a web page and also a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.